talking about the fundamental theorem of algebra, and we want to find all the zeros of the polynomial function. And so we know that we want to do synthetic substitution. So we can say P divided by Q, and that will help us decide what the factors are that we can check for our rational roots of this given polynomial function. And so we know that our P represents all the factors of our constant term, and our Q represents all the factors of our lead coefficient, which is 1. So in this case, that's not going to affect our possible factors. So we can just write down all the factors of 6. So we get plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. So those are all the factors that we can check. The other thing that we need to look at is we know that this is a degree 5. So the highest degree is degree 5. And so we expect that there's going to be 5 zeros. And when we use synthetic substitution, we know that we have to have descending order. So 5, 4, and then we're skipping 3. So I want to rewrite this just so I make sure I remember all the coefficients. And so we have f of x equals x to the 5th minus 2x to the 4th plus, in this case, we're going to have a 0x. We're going to add that one in there because 0x cubed, because we need to account for all the degrees in a descending order. Next, we come to plus 8x squared minus 13x plus 6. So when we use synthetic substitution, we're going to use those coefficients. And I'm going to start by checking positive 1. So I'm going to use synthetic substitution with positive 1. And I'm just going to write down the lead coefficients in front of each one of these terms. So we have 1, negative 2, 0, 8, negative 13, and 6. So we're going to remember that we add down and we multiply on the diagonal for synthetic substitution. So we're going to add down, we get 1. Multiply the diagonal, we get 1. Add down, we get negative 1. Multiplying the diagonal, we get negative 1. Add down, we get negative 1. Multiply on the diagonal, and we get negative 1. Add down, we get 7. Multiply on the diagonal, we get 7. Add down, we get negative 6. Multiply on the diagonal, we get negative 6. And then we get our remainder is 0. So because the remainder is 0, we know that 1 is 0. Now we're going to check, this is the remaining polynomial. This is the coefficients on the remaining polynomial. So this is the one that we're going to check next. And from my list, I'm going to check negative 1. And we're going to use what we had before. So we're going to use 1, negative 1, negative 1, 7, and negative 6. We're going to add down and multiply in the diagonal. So we get 1, negative 1, negative 2, positive 2, 1, negative 1, 6, negative 6, and then we get negative 12. So that's the remainder is negative 12. It is not a 0, so negative 1 does not work. So we need to move on, and we need to check another example. And I'm going to try 1 again. So I'm going to try 1 this time. And because it didn't work for this polynomial or these coefficients of the polynomial, I need to try this one again. So we're going to take these values again because it didn't work, and we're going to put them down and try it again, but this time we're going to try it with 1 instead of -1. So 1, -1, -1, 7, and -6. We're going to add down and multiply in the diagonal. So we get 1, then we get multiplying the diagonal, we get 1, add down, we get 0, multiplying the diagonal, we get 0, add down, we get -1, multiply on the diagonal, we get -1, add down, we get 6, multiply on the diagonal, and we get 6, add down, and we get 0. And so 1 is another 0. So now we know that we have a multiplicity of 2 at x equals 1. We'll be able to see that on the graph in a little bit. So we're still working on this. This is the remaining polynomial down here. So we're going to substitute these values back in for synthetic substitution. And we're going to pick the values of, those are the 1, 0, -1, and 6. And I'm going to substitute in -2. So I'm going to substitute in -2. And we are going to add down and multiply in the diagonal. So we get 1, -2, multiply on the diagonal, add down, we get -2, multiply on the diagonal, and we get 4, add down, and we get 3, multiply on the diagonal, we get -6, and then we have 0 when we add down, so this is remainder 0. So -2 is a 0. Now we have our remainder, our constant, our linear, and our quadratic. And at this point, we need to write out the remaining polynomial that we have. So x is equal to 0. If we write that in factored form, it would be x minus 1. And then down here, we had x is equal to 1. So again, that's x minus 1. That was our double root, or our multiplicity of 2. And then we have -2. So that's actually adding 2. And then we have our remaining polynomial here, where we have x squared, or 1x squared minus 2x plus 3. And that's our quadratic left at the end. So we have x squared minus 2x plus 3. So this is where everything came from. We calculated that 0 from this synthetic substitution. Then we calculated our next 0 from that synthetic substitution. We figured out -2 was a 0. And now we're left with this polynomial left, with that quadratic. And for this one, we're going to have to use the quadratic formula to figure out what our last two zeros are. So x equals, we'll slide this over, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to use that quadratic formula, and we're going to use, a, in this case, a is equal to 1, b is equal to -2, and c is equal to 3. So we can substitute those into the equation. For the quadratics, we get x equals -b plus or minus b squared minus 4 times a times c. And then all over 2 times a. We'll substitute those values in. So our b value is -2. Oh, forgot my squared term here, so I want to square this. -4, a is 1, c is 3, and a is 1 again. And then we can start simplifying this. So we get x is equal to negative times negative is positive, plus or minus -4 or -2 squared is 4. And negative 4 times 3 is negative 12. That's all under the radical. And we're going to divide by 2. Under the radical, we get negative 8. So x equals 4 plus or minus the square root of negative 8 all over 2. Now we can simplify, rewrite our radical. We can rewrite it as the square root of 8 times the square root of negative 1. And we know that the square root of negative 1 is I, and we can simplify the square root of 8 as 2 times the square root of 2. And so that's how we can simplify this radical here. And we can rewrite this as x equals 4. Sorry, that's not 4. This should be 2. I don't know where that 4 came from. That should be 2. Negative times a negative is 2. Plus or minus, and then we simplified our radical, 2 times the square root of 2i. And this is all divided by 2. Now we can take this 2 and distribute it to both our terms in the numerator. And that'll help us simplify it a little bit further. So 2 divided by 2 is 1. Plus or minus 2 divided by 2 is 1, so we'll leave that off, and then square root of 2i. And so we have 1, 2, 3, and then we have 4, 5 zeros. And so our solution to this is x equals, we know that we have a solution at negative 2. We know that we have a solution at positive 1. That's actually a double root or a multiplicity of 2. And then we have 1 plus or minus the square root of 2i. And that's both of those over there. So those are our solutions. We have 1. We have a double root here, so 2, 3. And then 4, 5. And we can check that out on the graph. Here's the function that we have graphed, and we see that we have one solution at negative 2, and then we come down and we have our tangent to the x-axis here at 1, so we know that that's going to be a double root, which we actually calculated, and the other two are imaginary solutions, so they do not cross the x-axis.